Okay, today, and I was just telling Kinley this, today we're going to go over section 5.4. And if you're in the spring 21 semester, if you're watching this semester, um, I'm going to also try to get to 5.5 today because section 5.4 is not that long of a section. It's really an introduction to factoring. We're going to go over greatest common factor, and then we'll go over factor by grouping. And the reason I emphasize factor by grouping, which we'll get to after just GCF stuff, is that it leads me into the way I factor trinomials. In 5.5, once we get there, we'll be over factoring trinomials. So this all builds on itself. So the more we understand in 5.4, we get the homework done, the way I factor in 5.5 is just super easy if you have this 5.4 section down. Okay, so first let's talk about greatest common factor. Look, the greatest common factor between a polynomial or factoring out a polynomial should be the first step when you're factoring. Identifying the greatest common factor really is the first step when you're factoring. So if we looked at something very basic, if we had like 4x squared minus 8x plus let's say 10. Okay, we've got this trinomial, and the goal here really is to factor out. And what factoring really means is that we're going to go from addition or subtraction of terms, like we talked about in the last lecture, and then we're going to turn it into multiplying. Okay, because to factor means you're really kind of creating multiplication. You're creating two factors, and factors are just terms or polynomials that are being multiplied together. Okay, so if we look at this one, this should be pretty basic. The goal is to see what divides into every single term. So if we looked at the 4x squared, the negative 8x, and the 10, we'll see that all of these are even, right? So they're all divisible by 2. So we're going to write that. That's actually going to be the GCF for this question, or for this example. So the GCF is 2 because all 3 terms are divisible by 2. If you look at the first term, you just have to divide the 2 out, right? 4 divided by 2 is 2. We didn't take an x out, so we're going to leave it there. Negative 8 divided by 2 minus 4. Now, again, we didn't take an x out, so the x stays. And then 10 divided by 2 is just 5, okay? And what you've noticed, we've gone from just addition and subtraction of a polynomial to multiplication. We have 2 times 2x squared minus 4x plus 5. We've created multiplication. Okay, kind of neat. Now, also to know that you're done, or a kind of a quick way to check it, you can multiply it back through. But before you do that, you need to look at the inside polynomial and see if there's anything else that's divisible into all 3 parts, which we definitely do not have. I mean, we had 2x squared, negative 4x, and 5. There's nothing divisible into all 3 of those. And the real way to check these is to multiply it back through. So this would be a quick way to check it. So this is just me checking. If I multiply the 2 back through, I get 4x squared minus 8x plus 10. Hey, that's what I started with, right? So therefore, this would be my solution, right? Or not solution, that's just my answer. Okay, that would be my answer. We factored this trinomial. Now, this is just factoring using the greatest common factor. Greatest common factor. We're going to go over a few different factoring methods and kind of special methods of factoring. But for now, it's just seeing if every single term has maybe a variable or a number we could factor out. So let's look at another example. Let's kind of kick it up a little bit. If we had, let's say, 12x squared y to the 5th minus, let's say, 15xy to the 9th. I'm just making one up. And then lastly, let's say plus 3xy. Okay, so we've got 12x squared y to the 5th minus 15xy to the 9th, and then plus 3xy. Now I need to see if I can factor something, or if I can divide something into all 3 of these, right? So we can factor it out. Well, if we look at the 12, 15, and 3, we can definitely take a 3 out. So I'm going to write that down. And then I'm going to look at the x's. And now the goal is to really find the smallest x. So we've got x squared, x, and x. Well, there's at least an x in all of them. I'm not going to take out an x squared, even though it's in the first term. We don't have x squareds in the second or third term, right? We only have x's. So, and then let's look at the y's. Y to the fifth, y to the ninth, and y. Oh, again, I'm just going to take out a y, okay? Because I've got at least a y in all three parts. And now I'm going to divide this 3xy into all three of these. And this is why we went over that 1.67 section. Remember, it was dividing exponents. And then really, even yesterday, the multiplying exponents kind of leads to this. We're kind of doing it backwards, actually. So let's look at the first term. So if we divide the 12 by 3, we get 4. X squared, we take an x out, we're left with x. And notice, 3 times 4 is 12. X times x gives me x squared. You can kind of check this along the way. If I divide a y out of the y to the fifth, I get y to the fourth, right? Y times y to the fourth, y to the fifth. Boom. I've got my first term. And if we look at our second term, I'm going to keep the sign because I didn't take the sign out. 15 divided by 3 is 5. X divided by x, okay, that's out, right? That cancels. So because we factored it completely out. Y to the ninth, and y, that's going to leave me with y to the eighth, okay? And then lastly, oh, wait a minute, this whole thing divides out. 3xy divided by 3xy. Now, you got to think about this. If you divide 3xy by 3xy, you're not left with 0. A lot of students want to stop here and put a parentheses, but you got to think, if we were going to check this, we would need a placeholder, right, to get back to the original polynomial. So what we need to do is if it divides completely, we need a 1, a positive 1. Again, we're going to keep the sign, so positive 1. And notice, if we look inside this set of parentheses, nothing factors out. 4xy to the fourth minus 5y to the eighth plus 1. There's not a common factor here because of the 1, right? We almost have a y, but that last term does not have a y, so we can't factor it out. And we kind of check these along the way, but if you want to distribute it back through, you'll see that you wind up with the original polynomial. Okay? The original polynomial. Great. Okay, let's keep rocking and rolling. Let's see if they throw something weird. Okay, I'm going to look in the homework real fast to see if there's just something weird. Maybe I'll steal one and do an example of it. Yeah. Let's say. Well, I'll tell you, like 26. We've got this is 26. If you're looking at the book, it's on page 378. 12 b to the fourth minus 3b squared plus 1. And the question states, I believe, factor out the greatest common factor. Let me make sure. You factor out the greatest common factor. So if we look at this one, though, look, 12b to the fourth minus 3b squared. Okay, we're good there. We can factor 3 out. But we've got a positive 1. There's nothing common in all three of these terms because this 1 is messing it up. Okay? If we didn't have the 1 there, we could definitely factor out what, like 3b squared. So because the 1's there and there's nothing common, what we're going to say is no common, I don't know why I wrote a G there, no common factors. Some books call this, because it's not factorable, they'll call it prime. So it means the same thing, right? If you're only divisible by 1 and yourself, then you're considered prime. So, okay, so be careful of that. That was the only real goofy thing I've seen in here that's different, okay? And now I'm going to go over something that actually leads us into the next part of 5.4. So to do this, I'm going to do a little exercise, a visual exercise here, okay? And I might use different, no, I'll use the same color. So this is a very visual exercise, but I need you to really watch this to grasp the concept. So let's look at a basic common factor. Let's say I had x, y plus 2y. And I ask you to factor this out. You would tell me, oh, that's easy. It's just y. Y is the common factor, and you're left with x plus 2, right? Okay, because y is divisible into both of these, right? So let's look at another one. Let's say I had like x z squared plus 2z squared. Well, you'd say, hey, Mr. Shirley, you just replaced the y with z squared. And I'm going to say, yeah, you're right, because this is leading to an important concept. So we factor out the z squared, and we're left with x plus 2, right? So if I put in, let's say I put in x times, you know what? Hold on. I will use a color. Let's say I put in like x times an apple plus 2 apples. Okay. Well, guess what? There's an apple in both of these. So it gets to factor out. And we're left with x plus 2. Okay. So the idea here, though, is it doesn't matter what is here as long as it's the same. As long as you have the same exact variable, fruit, or even binomial. So this is where I'm going to kick it up. So it doesn't matter what's the same. As long as it's the same, it factors out. Okay? So let's look at this. If I have x times y plus 1 plus 2 times y plus 1. Okay? That's just our apple now. The y plus 1 is our apple. And look, it's the exact same. Y plus 1 is the exact same as y plus 1. If this was y plus 1 and y minus 1, we wouldn't do this, okay? We couldn't factor it out. But because it's the exact same binomial, this factors out, and it leaves us, again, with the x plus 2. It's what's in front of the term, or the binomials, I should say. So x plus 2, okay? So kind of neat. And now this is still just GCF, right? The common factor is y plus 1. We're factoring it out, and it leaves us with y plus 2. Pretty neat stuff, okay? So let's look at another one. Let's say I had, I'm going to steal this straight from the book. This is number, I think, 20. Yeah, number 20 in the book. I've got 2 times x minus 4 plus 3y. Let me get my angle kind of right. 2 times x minus 4 plus 3y times x minus 4. Okay? As long as these are the same, you can factor it out. And it leaves you with x minus y as the common factor, right? And then 2 plus 3y as your other factor. And notice we've got 2 factors, okay? So it's a very, this is a kind of a visual way to teach this, or by example, but it's kind of neat. And when you see it, it's really easy. Hopefully at this point you're going, oh, this is just really easy, Mr. Shirley. You're right, but if I would have just thrown this at you like this and said, okay, factor it, a lot of times students don't see this. They want to distribute the 2, distribute the 3y, right? And it makes sense because order of operations says get rid of the parentheses first, right? Well, for this example, we're not going to get rid of the parentheses because they match, okay? We're not going to get rid of the parentheses because they match. So if we look at another one, I'm going to steal another one from the book because I don't feel like being creative today. Let's say we had, oh yeah, this is a good one, a little different. Let's say we had 9x, this is number 22 in the book, times y minus 2 plus y minus 2. Okay, so again, we've got matching coefficient, or matching factors. The y minus 2, that's our apple, right? So we're going to take the y minus 2 out. But when we do that, we've got a 9x, and remember, this really has a 1 right there. It's a placeholder thing, right? When you factor it out, you have to have a 1. If this was just x, if it was 9x, or let's say y, if it was 9xy plus y, we'd have a 1 there. So it's gonna leave us with 9x plus 1, okay? 9x plus 1, kind of cool, okay? Pretty cool. Okay, so that's still just greatest common factor stuff, but we're about to use that in factoring trinomials by grouping. So that leads us to this. Factoring, or not factoring trinomials by grouping, just factoring by grouping. Factoring by grouping. Okay, it's the second kind of concept in 5.4. Factoring by grouping. Now, the rules with factoring by grouping, to start with, you have to have 4 terms. So if you see 4 terms, I need your brain to think, hey, I wonder if we can do factoring by grouping, okay? So if you see 4 terms, now we might not be able to, but I want you to think, can we do factor by grouping? I'm gonna teach this with a very, very basic example, and then I'm gonna kind of throw different ways it can come at you for it. But factor by grouping looks like this. I'm gonna steal one directly from the book. So this is number 30 in the book. A, B plus 2A plus 5B plus 10, okay? Notice we have 4 terms. We have 4 terms. So that's the kind of indicator to use factor by grouping, because it's not always going to say, hey, factor this by grouping, right? It'll just say factor completely. And if you see 4 terms, your brain needs to go, I need to see if we can do this by grouping, because it'll make our life a lot easier, okay? Okay, so how do we do this? Well, I'll tell you, the first step is that you have to have a plus sign in the middle, okay? If you don't have a plus sign, we'll deal with that. I'll do that on the next example, okay? I'll show you how to deal with it. But what we're really going to do is we're going to split apart the first 2 and the second 2 terms and group them together. So I'm going to put parentheses with the sign too. So if it's positive, it's going to be a positive 5. So I'm going to group AB plus 2A, group that together. And then I'm going to group 5B plus 10. And there's always going to be a plus sign. So if this was negative, what I would have done is made this -5 here. And I'll do that on the next one just to show you what I'm talking about, okay? Just to show you what I'm talking about. So I'm going to group, this is called factor by grouping because we're grouping the first 2 together and the last 2 together, okay? That's the first step. So group the first 2 and the last 2. Then we're going to take the GCFs out of these 2 parentheses, but the goal is to get the parentheses to match. If they can match, we can factor it out like we did just a second ago, okay? If these binomials matched, we could factor them out, just like we did in these last few examples up here, okay? So let's look at this. AB plus 2A. Oh, they both have an A in there. So I get B plus 2, right? So if I look at 5B plus 10, notice I could factor, well, there's a 5 and a 10. I can factor a 5 out, right? But when I do that, it's going to leave me with B plus 2. Oh, man. So first step, parentheses. If you want to write this down, first step, parentheses, around the first 2 and last 2, has to be a plus sign right here. Second step, I've got to factor both sets of parentheses to make them match, okay? And then I'm just going to factor that out, B plus 2, because it matches. And remember, it leaves me with A plus 5. And look, we factored this. We went from addition, for this example, of 4 terms into multiplication of 2 binomials. That is such a big deal, okay? I know. You're like, no, it's not, Mr. Shirley. It's not in the scheme of life, okay? But it is a big deal in mathematics because we can do some neat stuff here in the next few, actually not the next section, but like in 2 sections. We can do some neat stuff if we can factor polynomials, okay? If we can factor polynomials, we can do some neat stuff with it later, which we're going to do, okay? And it'll be on this next test, actually. Okay, so there's an example. This is a very, very basic example. Step 1, parentheses around first 2 and last 2, have to have a plus sign in between. Factor each of them out, factor completely to get them to match. And then once this matches, we know we can factor it out, and it leaves us with the coefficients, really, the A and the plus 5. Okay, so let's do another one. Let me do it right here. But I'm going to do one with a minus sign just to show you how to deal with it. Stealing ones from your homework here. Okay, this is number 32. We've got BC plus 8C minus 3C minus 24. Okay, BC plus 8C minus 3C minus 24. Okay, so here's how we handle the minus sign. Notice there's a minus sign in the middle. we need a plus sign. So when we group these together, BC plus 8C is going to go together. And then you're going to bring this sign in, 3C minus 24, and you're just going to create a plus sign right there, okay? You bring the negative 3C right there. So nothing changes. Since it's a plus sign, think about this. If you distribute a plus sign, you just get the same exact thing. It doesn't change, okay? We haven't changed anything. We've just manipulated this polynomial like a good ex-wife or girlfriend, okay? We've manipulated it into what we need, okay? Okay, so now let's factor each set of parentheses. So I'm going to factor a C out of here. I get B plus 8, okay? And then, now remember, guys, the goal is going to be to make a B plus 8. And if, look, 3 and 24 are both divisible by 3, but the signs are going to be wrong. So I need to factor a negative 3 out. And if you don't see that right away, that's fine. But you'll see that both the signs will be backwards. Why in the world is that a C there? Hold on. Did I write this wrong? What number did I say this was? 32. Oh, you know what, guys? Hold on. I wrote this down wrong. Hopefully you're not using a pen. That's a B right there. Oh, no. Oh, no. Let's just mark this up. That was 8B, not 8C. I don't know why I wanted to write 8C. So go back. It's BC plus 8B minus 3C minus 24. Again, this doesn't change. But notice now, instead of factoring a C out, we actually need to factor a B out. C plus 8. And then now we need to factor, again, that negative 3. And we're left, by factoring out the negative 3, it leaves us with C plus 8. Okay? And then both of these match. That leaves me with C plus 8 times B minus 3. Okay? C plus 8 times B minus 3. We'll do one more of those because I goofed that one up. Okay? We'll definitely do one more because I goofed that up. Okay. So let's look at one more. Let's do one like at the end. Maybe that means they're harder. Now, like this is number 72. It's like the very last one. 72 says x cubed minus 2x squared minus 3x plus 6. Okay, good. So this one gives us a minus 1, so we can do an example like that. Actually, I'm going to pause here for just a second. I want you to try this one, and then I'll come back to it. So I'll give you a minute to try it if you're following along at home, just to see if you're in the same spot. Give you just a minute. Okay, let's look at this. So again, I've got a minus sign, so I got to group these and then just bring that minus sign in. So x cubed minus 2x squared plus negative 3x plus 6. Okay. Now look at this these first two terms here. I got an x cubed and a 2x squared. Well, remember, you're going to factor out the least of the x's. So x squared is what I'm going to factor out. I'm left with x minus 2. And then I'm going to look at the second set of parentheses. Now I got to get these to match. Okay, look, guys, if I factored out just a 3 here, it would leave me with negative x plus 2. But the signs would be off. So I need to factor out a negative 3. And by doing that, by factoring out the negative 3, it leaves me with x minus 2. Okay? Look, I distribute it back through, negative 3x plus 6. Okay? And notice now these match. So if I factor out x minus 2, I'm left with x squared minus 3. Pretty cool. Okay? Pretty nifty. So for homework in this section, it's on page 377. And I want you to start actually on 11 through 71 odd. That's like 30 questions. Okay. 11 through 71 odd. If you did like every other one, you'd probably be fine as well. Or every other odd, you'd probably be fine. You did every other odd and then came back, and if you needed more work, do all the odds. Okay. But homework for section, this is 5.4, is going to be from on page 377, 11 through 71 odd. Okay. Kinley, do you have any questions before we go on to the next one? If not, it's not a big deal. You don't have to like turn on your thing. I'm going to stop this. So what I'm going to do is I'm going to stop this, and I'm going to create another lecture video